Let's talk about the frame, the structural foundation of any user interface in SysML modeling. A frame is the structural foundation of any user interface model in SysML. It defines the boundary of the UI, what's inside the window. Let's talk about something familiar. Think about the calculator app on your laptop or phone. When you open it, the number keys, the result display, and the function buttons all live inside one tiny window. The outer boundary, the window itself, is the frame. Or consider a music playing app. Everything you need, your playlists, the play button, album art, and navigation menu, live inside one resizable application window. That, again, is the frame. Without a frame, the interface does not have a defined scope. It would not know what it's enclosing or what it represents in the system. In SysML modeling tools like CATIA Magic, every frame must be connected to a classifier. In all practical terms, a classifier is generally a block, but it could be another UML class or component. Maybe it's an activity, but generally speaking, it's a block. That classifier serves as the simulation context. It tells the frame what model elements it can see and interact with. The frame needs to know what it's framing. Without a classifier, the frame would have no access to the underlying system logic or data. It would just be a shell. The things the frame can then see might include value properties of that classifier, reference or part properties of the classifier, behaviors or operations that the classifier might own, signals that trigger actions, etc. To display these types of properties in the frame, it's common to nest panels and group boxes inside a frame to organize those properties and controls. Let's talk about where a frame comes from, because it's important to understand that the frame is not part of the SysML language itself. The concept of a frame, along with other UI modeling elements like panels, buttons, and checkboxes, is provided by the UI prototyping profile in CATIA Magic. These elements are implemented using UML extensions to create a stereotype. A stereotype in UML is a way to take a standard modeling element, like a class, and extend it with additional meaning or behavior. So in this case, a frame is actually an extension of a component in UML. The frame stereotype tells the modeling tool how to render the element, how to simulate it, and what tagged values it can expose and configure. This is what allows us to drag a frame onto a user interface modeling diagram and have it behave like a functioning window in the simulation. Let's take a closer look at how that actually happens. In this profile diagram, we see that not only is the frame an extension of a component, but it also inherits the attributes of the title, icon, and inactive elements. The title stereotype has the attribute title, which is defined as a string with a multiplicity of 1. This defines the text shown in the title bar of the frame window when the simulation runs. It also inherits the icon attribute from the icon stereotype. This allows you to assign a graphical icon to the frame. The 0.1 indicates that this is an optional attribute, but if used, it visually enhances it. The icon is a small image displayed in the top left corner of the shape when it's displayed on the diagram. It might also appear in the containment tree or in various pop-up windows. The inactive stereotype has an attribute named inactive, which is typed by a Boolean value. This adds a control attribute to enable or disable the UI element. If it is set to true, the frame should appear grayed out or unresponsive during simulation. The frame stereotype itself adds 2 Boolean attributes, minimize and maximize. This should allow the window to be minimized or maximized during simulation. However, occasionally the execution of these are not always perfect when we go to implement them in our tools. All of these attributes, title, icon, inactive, minimize, and maximize, are considered tagged values when you instantiate a frame in the model. They let you customize the appearance and behavior of the simulation window without any code. And because they are part of the stereotype, they are consistent and traceable within the model. A frame is always the top-level container in a user interface modeling diagram. Everything else, labels, checkboxes, and input fields, must live inside of it. And during simulation, the frame defines the launching window for the user interface. It's the frame that opens as the interface. It's the user-facing part of your simulation. In short, the frame is your canvas, your window, and your starting point. Everything else is built inside of it.